Welcome to the How to Program with Java podcast, where all you need is the desire to learn, and you too can become a Java programmer with absolutely no knowledge of programming. And now, your host, Trevor Page.
Hey, ladies and gentlemen, boys and girls, children of all ages. Welcome to episode number 59 of the podcast, the How to Program with Java podcast, to be specific. Great to be here, great to be back. I've taken just 1 week off because, as you may or may not have heard about, I splurged and got myself a new puppy. So she's actually standing next to me right now, and for the moment being a lovely young lady, but it looks like she's waking up because I'm now talking into my microphone, so she's probably going to be a handful. In any case, I haven't been getting much sleep, and she's really been disrupting my work schedule and getting these things recorded, so I apologize for that. But in any case, she's plenty of fun to have, and we'll see how what the future brings for myself and this new puppy. So, in any case, let's get on to the fun stuff. So this week we had a review come in, a 5-star review through iTunes, which is wonderful. Came in from the UK, from, it looks like reviewer name is James_Tron. He says, this is excellent and he can't believe it's free. He says, this is complex concepts explained brilliantly. Great for beginners, or a recap for the things you forgot from university. So thank you very much, James, for submitting that review. If you have the inkling to submit a review yourself, you can go to howtoprogramwithjava.com/love, Love, and you can leave a rating and review, and any 5-star reviews I will go ahead and read at the top of the next episode. So, thank you very much for all of you who have already left a review, and if you haven't done so yet, what are you waiting for? Let's get to it. So, let's, I guess, jump right into this episode for today. We're going to be talking again about Hibernate. We're wrapping things up, and unfortunately coming to a close with this Hibernate series that I have been doing. Some of you might be elated by this, some of you might be a little bit depressed, but hopefully you guys have learned a whole lot along the way and have gotten just massive value from all these podcasts. So just like James says, he can't believe it's free. I can't believe how much fun I have with these things, even though they're free. So I want to continue to do them, and I probably will be in the future series where I'm probably going to be shifting over to something like HTML and CSS and JavaScript. I don't really know. These are all topics that sort of revolve around using Java as a web application programming language. So we use it as the business layer, where you have the presentation layer being things, like I said, like HTML, CSS, and JavaScript. And then you have the database layer, the data layer, which is obviously something like Hibernate that you can use as your persistence framework. So that's sort of the huge, 50,000 foot view picture of this whole thing. You break it up into the presentation layer, business layer, and data layer. We've already talked a little bit about business layer, which is really the Java stuff, and I'm obviously going to be going back into Java stuff because we haven't really covered some really advanced topics that obviously we need to get into, as well as some more, I suppose, time sensitive or time, I don't know what the word is, but things like Java 8. And perhaps Java 9 on the horizon. So these sort of time-sensitive topics that I haven't even touched on yet. So there's still plenty to talk about. But I'm probably going to move into HTML and CSS and just give a little bit of info there so you guys can be well-versed if you do want to jump into doing a web application development, which I think is besides mobile, the future of all programmers and where you should be sort of aspiring to be if you want to pursue a career either in a professional field, like a professionally hired and working programmer, the full-time 9-to-5er, or even an entrepreneur like myself. Without the knowledge of HTML, CSS, JavaScript, as well as Java, Spring, and Hibernate, I would not have been able to do everything that I've already done. So that's why I'm teaching it to you guys. So, having said that little rant, let's, like I said, focus on the later half of our, or maybe even later quarter of our topics with respect to Hibernate. So this one, let me just pull up my clever title that I chose for this particular episode. It's going to be how to fix duplicate data from Hibernate queries. So I've touched on this very briefly before where I talked about duplicate data, but now I really want to dive into this problem in detail because most likely some of you have hit this problem and you might not know why it is that you are in this situation, okay? So I will tell you why it is. So this really applies to people who've really been using Hibernate and have already integrated it into their applications and whatnot. So these are the people who are really going to get the most benefit from this. For those of you who have not used Hibernate yet in any sort of capacity, in any sort of program, still you should listen up, because this is a very valid topic that you might be able to fix your issue, or at least understand your issue, your problem, before you even hit it. So that's obviously a plus or a bonus if you can go into it with that foresight. So, how to fix duplicate data from Hibernate queries. So this problem was the bane of my existence when I first started using Hibernate, because I had no idea where my problem was coming from. I was doing these queries, and I was getting multiple duplicates coming back, duplicate data. So if you're executing a query and finding that you have a bunch of duplicate records and having a clue why, then obviously you're in the right place. You're listening to the right podcast. I know one person has already commented on the blog back when I sort of gave the little hint about this topic and suggested a quick solution. They already said, "Oh my God, I was in this situation. I'd hit this problem, and thank you so much for addressing it, because I was able to fix my my workaround, or rather get rid of my workaround, which is pretty apparently a pretty obscure framework of coding and ifs, thens, and elses and all that kind of stuff. So in any case, this is useful stuff, so pay attention. So yes, like I was saying, to paint the picture, you are executing some sort of a query with Hibernate, and you are getting duplicate data. So what do I mean? What do I mean by duplicate data? Well, the example that I'm going to be talking about in this session is going to be using the user class. So we've talked about users already, ad nauseum. So in this discussion, it's going to be no different. We're just using a typical user class with username and password, etc. And then we're also going to be using a relationship that joins the user class to something like a login history class. So the login history is just going to be exactly what it sounds like. It's going to keep track of the date and time that a particular user has logged into our system, because that's often useful to know when they logged in, when they logged out, that kind of thing, so we can track, overall average usage time when users are in our application or what have you. You can think of Facebook and whatnot. Like, how does Facebook know how much time we spend on average on their website? Well, I'm sure they keep track of when people logged in and when they logged out, and so on and so forth. So that's what we're going to be talking about today. Now, that is a one-to-many relationship between these two objects, between these two tables. One user can be tracked back to any one of many entries in the login history table, but any one entry from the login history table can only be tracked back to one user, because it wouldn't make sense for one login record to map back to multiple users, right? That just would get kind of confusing. So it's a one-to-many relationship. And the problem that occurs here with getting duplicate data is, well, first of all, and let me talk about the duplicate data. So when I haven't yet got into that yet. Clearly my brain isn't working right now. So what I mean by duplicate data in this case, with this scenario that I just mapped out, is you query the database and you expect to get one user with a bunch of rows with respect to their login history. But instead what you get is, let's say we have a user who has logged in 3 times. So they have 3 entries in their login history table of the database. And you expect to, when we query for that user, you expect to get one user with 3 login history objects inside of it, right? Makes sense. But what you do get instead of that is you get 3 user objects which have the same user information. So let's say, user's T-page. So you have 3 T-page user objects, but inside of each of those 3 user objects, the 3 T-pages, is each unique login history row. Okay, so maybe we have a user T-page with login on September 10th, and then user T-page with login on September 12th, and then the user T-page with login on September 15th. But that's not how you want it. You don't want 3 identical user objects with 3 unique login history rows inside of them. You want one unique user class, user object, within it, the collection of objects being the login history objects, of which there are 3. Okay, so why is this problem happening? Okay, why are you facing this situation? Or rather, if you haven't faced this situation yet, what could arise? What situation could arise that you would find yourself having to deal with this particular problem? Well, this particular problem is typically caused by having left joins. Okay, left joins or optional joins, as they're called inside of the Hibernate framework. Okay, so left joins, we've talked about them before, and I think I've talked about optional joins anyway. If I haven't, then I'll refresh your memory. A left join is done when you want to connect yourself to a table, connect your relationship between two objects, but it's like it implies an optional relationship, which means that if there is no correlation, if there's no match between the two tables, then you'll still see the rows inside of from the left-hand side table. So that's really a complex way of saying that here in this situation, let's say we have a user row who has never logged into the system before. Okay, they've never logged into the system, and you want to be able to see a list of the users as well as their history, their login history. Okay, so what happens if you don't use a left join? What happens if you use just a regular inner join? Well, if you use a regular inner join, then every single user who's never logged in will not be included in the query, because an inner join gets the actual intersection between the two. There has to be a matching row on the other side of the join for it to return any data at all. Okay, so if a user is never logged in, you're not going to see any rows, and that's not what we would want. Okay, we want to see their login history if they happen to have any, but if they don't happen to have any, then we still want to see that user so we can say, okay, that user does not have any login history associated with them. Okay, so we would use a left join to do that, which is, like I said, an optional join. So using a left join, we will not exclude the user rows who have never logged into our system. Okay, having said that, like I said, the problem of duplicate data comes up when we're using these left joins, these optional joins. So when you have a base object like user, and it joins to another table or object in an optional one-to-many or optional many-to-many format, then you may get duplicates. So if you are keen and you've been paying attention, you may understand why we would get duplicates. Okay, I just explained it to you. When you run a typical left join situation on Hibernate, or rather on just a regular SQL, in a regular SQL situation, so if we're using MySQL, we run a left join between users and login history. What happens? Well, the SQL will return multiple duplicate rows for the user object with each of the unique joins on top of them. Okay, so you'd see the joins between the user and the login history, and it would give you the multiple rows. Well, what happens is the Hibernate system, when you're using the optional joins, the left joins like that, it doesn't try to massage the data at all. It just takes the data as it comes and puts it into a whole bunch of duplicate user objects, which is pretty annoying. Now, this actually only happens in one particular scenario, or rather, probably two different things need to happen for this thing to go wrong. And I just happen to have those two things happening. I just happen to have this ideal scenario set up where I would run into this problem. So what happens? Well, two things need to happen. One, inside of your user object, you would need to have joined to the login history objects, you would need to have a collection, a list. You need to have a list connection or collection. Geez, I'm getting my words mixed up. Between the user and the login history. So what that means is inside of your user object, you would have a list of login history objects. So the list is the key element here in this particular dilemma. If you're using a list does not have any means by which to eliminate duplicates. Okay? So that's the first side, that's the first half of the problem. Now, the second half of the problem is if you're using something like an eager fetch, or you are actually initializing the join if it's a lazy join. Okay, so in the scenario that I was running into, I had all of my joins set up as eager joins. Okay, now I've talked about eager versus lazy loading in a previous episode, so I won't go into that right now. But if you have an eager loading situation, or like I said, if you've initialized your lazy load to connect to and load from the login history table, then you will also see this situation arise. So eager fetching or lazy fetching with the load being initialized, as well as a list collection being used as a part of the join to actually represent the many side of the relationship, and you have set yourself up for this problem to actually occur. So what happens is, like I said, Hibernate does the query, and potentially sees that there are multiple, or does the optional query and sees that there's multiple entries, and it puts them all into the list object. Okay, so what happens is it loads them into the list collection exactly as they are in the database, which means you'll get user T page with login history row 1, and user T page with login history row 2, and user T page with login history row 3. Okay, all those will be separate objects stored inside of the list. So there's going to be 3 entries inside of your list with 3 very similar user objects, and each having their own unique login history row associated to them. So there you go. That's the problem situation. So obviously you want to know how to fix this problem situation. So how do you fix it? Well, there's 2 things you can do. The first thing you can do, let me just scroll around here, is to declare your joining object as a set collection. Now, this is what I hinted at in the previous episode where I talked about this problem, which was actually enough to help someone solve the problem, which was fantastic. But now, obviously, I want to go into a bit more detail about what's going on. So you can declare your joining object as a set. That's the first of 2 ways to solve the problem. The second of these 2 ways to solve the problem is to make use of something called the distinct root entity results transformer, which is a big mouthful, and I don't want you to get confused or intimidated by it, because it's really just 1 line of code in the end, and it's quite simple to set up. So we'll get there in a second, but first I want to talk about the first way to solve this problem, which is to declare your joining object as a set. So as I mentioned, instead of having your collection being a list, then you should change it to a set. So really, that's all there really is to it, is to do that. So when you have your user object, which has declared inside of it it was previously a list of login history rows, or login history objects, now we change that list of login history objects into a set of login history objects. So that's really all there is to it. It's not really any sort of rocket science going on here. So what happens in the background here is once you've changed it, so you need to change your instance variable from list to set, and you need to change your getters and setters as well, because they're going to have your getter's going to be getting a list of login histories, and your setter is going to be taking in a parameter list the list of login history objects. So you need to change those 2 up as well. But once you've done that, you can leave everything else as it is, and Hibernate will take care of the rest. Hibernate will see that it's a set, and it will manage, Java will manage the process of making sure that all you get back are unique objects, because one property of a set is to eliminate duplicates. So however it goes about doing it, I don't know the science behind it. I haven't actually gone in and looked and debugged the code line by line, because it just works. So however it works, it goes in and it sees that it's loading a user object that it's already tried to insert into the set before, and it doesn't insert that duplicate user object into the set. Instead, it intelligently takes the login history part of it and puts it and inserts it inside of the already existing user object inside of your set. And bada bing, bada bang, bada boom, you're done, and you are in a situation where you are laughing. Now, that sounds like, all sunshine and rainbows and ponies, but the problem with this is that if you have any sort of code in your program that relies on functionality that's unique to a list, then you're going to have a problem. And I know this because I've run into this problem before. So I changed everything from a list to being a set, but then I noticed I had a whole bunch of compilation errors all over the place, because I was iterating through a list previously, and I was referring to the index inside of the list. So if we go back to our collections 101 talk from, God knows how many episodes ago, probably, one of the first 10 or 20 episodes of this podcast, you learned about the difference between sets and lists. One difference between a set and a list is that sets do not maintain any sort of index. There's no ordering involved with a set, okay? Whereas a list has an index. There is ordering involved with this particular collection, this list collection. So if you at any point made reference to that index, so if you had said .get 0 or .get 1, .get 2 or something like that with that particular collection, that is now not going to be properly compiling code because you have changed that to be a set. And when you have a set and you say .get and you pass in an index, it doesn't work. Okay, because sets do not maintain index. Sets you need to iterate through sequentially from first to last, and there's no grabbing the middle one based on an index because it doesn't have one. So if you run into that situation, then this is where solution number 2 to this problem comes into play. So again, I hinted at this at the, nearish to the beginning of this episode, and that was to use, let me just scroll up here, make use of, to use the distinct root entity results transformer. I always need to go back and look that up to make sure I'm using the right terminology. But yes, so what the heck is that? What does a distinct root entity results transformer even mean? Okay, but obviously this is going to be something that's going to solve your problem if you need to have a list as your collection. If you need to maintain an index in some way, shape, or form, but you want to get rid of the duplicates, then you can use this solution. So it sounds obviously like pure gibberish, but thankfully, like I said, it's not hard to implement at all. All you need to make sure is that you use like this results transformer thing when you're building your query. Okay, so when I mean building your query, I mean when you have your code inside of your DAO object, wherever the code is being hit to actually query the database, that is where you need to insert the magic, this magic line of code that will solve all your problems. So for me, I'm building my queries using the criteria. So I'm using the session.create criteria, and I believe that this is what goes along with that particular API call when you're using the create criteria method. Now, I'm not sure if this will work for any other type of queries, so I'm going to have to suggest that you use it with the create criteria, or at least in tandem with that. If you are not using that, then you might want to consider moving towards it if this problem is big enough for you. So what happens is when you create your criteria, so I do session.create criteria, I specify the class that I want to be actually querying on, which in this case is a user class. And let's say I'm querying the user by or user table by username. So I'm saying, okay, I want to query it, and I want to say, get me all the users that have the username tpage. So in my code, I would have, I would add a restriction, and the restriction would be on the username property, and it would be equal to the username that I'm passing in to this particular method inside of my DAO. Okay, and then I would say .list. So this is nothing new. You've seen this before. This will return a list of users based on that criteria which we just built, but it does not solve my problem. That will indeed give me the problem of returning multiple duplicate rows of these user objects, and obviously you want to get around that. So how do we get around that? Well, before we actually, invoke the .list call to actually return our list, before we do that, we need to invoke one more thing. We need to say .set result transformer. Okay, so we're setting this thing called a result transformer, and inside of the brackets, we're going to pass in this constant called criteria dot distinct root entity. Okay, and distinct root entity are all capitals because, like I said, it's a constant. So this is a convention in Java is to use all capitals when it comes to using a constant. And distinct root entity is 3 words, and they're separated by underscores. So criteria dot distinct underscore root underscore entity, and that's it. Then you're good to go. Then you can say .list, and the magic will happen for you. So that you're telling Hibernate that you want to make sure that the objects that are being returned from this query are indeed distinct objects. We don't want to have repeated user objects being passed in, or rather returned by our list, because that's really, really annoying, obviously. So that is one way to get around it if you need to be returning a list of elements. Obviously, this isn't the greatest example because using get user by username implies that it's only going to be returning one user. But if you were doing another type of query where you're getting users by I don't know, creation date, and you give it a range of dates or something like that, and you're querying the database to see a list of users that were created between date 1 and date 2 or something, well, then you're going to have a whole bunch of users. You're going to want to have a list of these users, and you're going to want the list of users to be unique. Okay, and that's why you would use the set results transformer, distinct root entity line of code inside of your create criteria method call. Okay, so that's pretty much all there is to it about how you solve or go about solving that particular problem of having duplicate entries inside of your list. Okay, to recap, you can either change it so that you're using a set. Okay, but the downfall of using a set is that if you at any point need to make a call based on the index, so if you need to return an object inside of your set based on some sort of indexing order, then you're going to be you're not going to be able to do it, essentially. Okay, so that's kind of annoying. There are ways to get around it. You can use sorted sets. So you could use something like a tree set. I think a tree set will actually maintain order for you. And although I still don't know if that'll really help if you need to get at an object in the middle of the set. There's also something called a linked hash set. So these are all sort of types of sets that implement the sorted set criteria, the sorted set methodology. So maybe that's all you need in your as your requirements. Maybe that's all you need to do. Maybe the whole point of why you're using a list before is because you wanted the list. You sorted the list in some way, shape, or form. So now you can use this sorted set thing and get around having to use calls to the indexed spots inside of your collection. Who knows? I mean, I don't know what kind of requirements you're going to have or what kind of requirements you're going to run into for your particular situation. But these are just ideas for you. So you can use a set, or you can try using one of the sorted set implementations like tree set or the linked hash set. Okay, so there you have it. And again, linked hash set will maintain insertion order. So just like, I know I'm kind of going off on a rant here with a whole bunch of Java, technologically advanced type stuff, potentially technologically advanced stuff for your minds. Maybe it's not technologically advanced for you, and that's awesome. That means you're doing really well along your journey of learning Java. But it's okay if you don't really understand the stuff that's going over your head. You can always re-listen to this episode at the end when you need to really get this stuff solid in your mind. But in any case, the linked hash set will maintain the order of which you are inserting into the actual set itself, because it's a linked hash set. So when you have a linked, just like a linked list, you can say .next, and you'll be able to actually get the next element that was inserted into that particular set. Okay, so I mean that's a property. The property of the regular sets are that the non-sorted sets are that it sort of returns them as you're iterating through them. It returns them in whatever order it likes. Okay, it maintains some sort of an algorithm that will maintain its own order that to you will look like complete chaos. But you can get around that by using the sorted set implementations. Okay, and then obviously the second solution is if you need to use a list and maintain the ability to refer to the index inside of the list, then you can implement the what's called the results transformer distinct root entity solution, which is where you insert the one line of code into your create criteria call, where you say .set result transformer and say criteria .distinct root entity. Okay, so if you want to take a look at exactly what that code looks like, because I'm sure you're going to be confused about this, you can go to howtoprogramwithjava.com/session59, and you can see exactly what's going on inside of the show notes on that page. Sound good? So there you go. That's pretty much our episode for today. It's just hit the 30-minute mark, so it'll be a short and sweet one. And I wish you the very best, and I hopefully you'll go to the website, like I mentioned, howtoprogramwithjava.com/session59, and be sure to sign up for our email list, because you'll be able to get notified as soon as the next whatchamacallit goes live, the next podcast goes live, because I'm sure you guys want to know as soon as these things go live. And also obviously other updates and cool stuff coming down the pipeline as it pertains to Java and its related technology. So hop on our email list. You can do that at the very top of the website. You'll see a box where you can sign up. And if not, then, you're missing out. I would love to have you on my email list. I'd love to be able to chat with you. So get on there. What are you waiting for? And while you're at it, sign up for, or rather leave a rating and review by going to howtoprogramwithjava.com/love. And if you leave a 5-star review, I will read it at the top of the next episode. So having said all that stuff, I wish you the very best of luck. Hopefully you're having lots and lots of good experiences with Hibernate and Java in general, and hopefully you're also looking forward to our potential move very soon into the land of, the presentation layer land of JavaScript, HTML, and CSS. So can't wait to see you then. Take care of yourselves, and bye for now.
Thanks for listening to the How to Program with Java podcast. Please visit howtoprogramwithjava.com for more useful Java tutorials.